constructor is allocating them a default value because the return value is int. That's
Yes,
why the default
and
value corresponds to A and B is 0.
your chat box is activated now.
Even though both the
Am I
is same,
audible?
but I want to refer to
Right.
instance variable. I want to
Yes, very
assign
good. Yeah,
parameter
very good
value
morning
to
to
the
all of you.
instance variable. In that case,
Right.
I'll be
So,
writing here like
what we did
this.
last time? Have we done soft computing in detail?
But this
Have we
keyword actually,
done
this keyword
characteristics
is
of
used
soft computing,
to
examples of soft computing? Yes,
run
differences we have done.
instance
Right.
variable. Means
Yes.
this keyword
Today we
usually
will
not
do the
present in the
topic
current class object. So that's
uh,
why now we are
fuzzy
trying to
logic,
do it.
right?
So you can see if I
So first of all,
think of
I
this,
would like to.
suppose
I
A
have
is
showed you
referring
the
to the
syllabus also.
instance variable B, and this B is referring to the instance variable B. Now using this keyword, we are assigning the value that we are passing to the constructor
Before
to the
to
instance
start
variable,
the,
and now you are
we have
executing.
done the
You will see that
hybrid
value
computing.
when
Have we done hybrid
what is the
computing?
input value. So that's why I have seen in some of the programs that they are using this keyword.
Okay.
Because they are using this keyword,
So first
it
we
makes sense
discuss
the name of the
hybrid
instance
computing.
variable and parameter name are same. So in order to differentiate between those, like to which argument we are assigning which values. Right? Because on the left hand side we want instance variable and on the right hand side we want parameter value. So it need to be assigned to the instance value.
So
So
hybrid
that
computing is a combination of the two types of computings, that is hard computing and soft computing.
now this is basically rule of thumb.
So you have like this hard computing, and then
Yeah, the output was
sorry,
there, but
circles are
the
not so
output was zero
drawn well.
because the left hand side A, this A
Suppose
is
you have
referring to
this
this A.
hard
That means
computing,
I am assigning on the
and
left hand
then
side we are having the A and on the right hand side we are having the A.
soft
Both A
computing,
is referring to the
and this is your
this argument only. We are not referring to this one. It means we are not assigning value to the
the
instance
topic
variable.
is
If we are not assigning it, then what happens?
hybrid
Constructor is assigning
computing,
them the default value, which is zero.
right?
You see, I writing
Here you
double.
have
That's it.
hard computing,
Now you are going to get value zero.
right?
If from zero
And
you
here
proceed,
you have
now if
soft
you are not
computing,
assigning it, then
and
then
hybrid
because
combination
on the left hand
is
side,
the
what A
combination of
is and on the right hand side, what A is, both
this
are same. And both are referring to the instance
hybrid.
and not result. That's why we get it.
Hybrid
Now I am saying
computing
this
is
process.
the combination of conventional hard
This
computing and emerging
now you can see
soft computing.
this A,
So this is the
left hand side A is
hybrid
referring to
computing.
the instance variable.
So
Right hand side A
hybrid
is
computing, where
referring
it
to
is used, it is basically a, first of all, it
left
is a
hand side B is
basically a
referring to
combination of
instance
two
variable.
into solving a
Right hand
problem,
side B is referring to the
a
instance
particular
variable.
problem. So
And in this case,
few
we are going to
portion of the
basically use
problem can be solved
FOO,
using
current
hard
object
computing,
method.
for which we
Current
have mathematical
for both the
formulation,
instance,
right, for
that
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 particular part.
that will be the need to
But
resolve this
then we require a precise input,
this clear to all.
and there are some
So I
part of
hope
the
this
same
will
problem
this keyword.
may not have
Will be
the
targeted
algorithm,
in the number of programs.
and we can also
Yes,
do not require
you
the
have to use
accurate
the same
result.
thing.
So that
Because
part
we
can be
avoid
solved by soft computing,
making
right? So then mixing
unorganized
together is
expression as
called
a variable.
hybrid
If I can
computing.
do the
Means
same thing,
you have a one bigger problem.
constructor value
So
to A
some
and B.
part of the problem for
Then
which
you are
you
saying
have
it we are
mathematical
again going to perform
formulation
value.
can be solved by hard
Just
computing,
referring
right?
instead of working
But some other part of the same problem
I can
for which you do not have a
understand the
mathematical formulation,
schematic
right?
result.
You don't have the algorithm, so that part
Then we are in the
can be
process
solved
of
by using
FOO
soft computing,
constructor of
right?
I
So
think what we call constructor is like
this is the hybrid computing. We know uh, hybrid hard computing. If we know soft
so you can
computing,
see here
and if we know
we
some
are referring to
problems, so whatever
constructor
the characteristic
our
involved to the
constructor
solve
is
hard
this one
computing, way of soft computing. It can intermix the two approaches, then hybrid computing can be obtained. Right? When you have solved the problem uh, with the combination of these two types of computing, one part is solved by hard computing and one part is solved by soft computing. Mixing of these two is called hybrid computing. Right. Next is we start the fuzzy logic. So this is the main fuzzy logic. First, I would like to write the topic. Fuzzy logic. So fuzzy logic is an essential component for soft computing. So what are the core components of soft computing? What we discussed last time. What are the core components of soft computing? Fuzzy computing, right? Fuzzy logic, neural computing, evolutionary computing, and one more is probabilistic reasoning. So all these are core components of soft computing, right? So fuzzy logic is the component of soft computing, right? So to understand the fuzzy system, we should familiar ourselves with different terminologies. First of all, what is fuzzy logic? Fuzzy logic is a mathematical language to express something, right? So whenever anyone asks you that what is fuzzy logic, first of all, fuzzy logic is a mathematical language. So it is a mathematical language. Like other languages, fuzzy logic also has grammar, syntax, semantic, like other language. It is also used for communication. Right? As you know, language is used for communication. Similarly, fuzzy logic is also used for communication also. So there are other mathematical languages also like Boolean algebra, then relational algebra, predicate logic, predicate algebra. These are all mathematical languages, right? Which you have already studied in discrete mathematics. So, and but the fuzzy logic is the combination of all these languages. It is a combination of relational algebra and then Boolean algebra and then predicate algebra. Yes, students, are you getting? Please raise your hands if you are listening and getting. Right. Yes, out of 98 students, only few students responded every time. Why so? Yes, everyone should be interactive. Just be online. If you have any doubt, you can ask any time during the session, right? But be interactive. Okay, let's proceed. So, as I told, it is a combination of what's relational algebra, and relational algebra is applied on the sets, right? Operations are applied on the sets. Relational algebra, it is applied on sets, and then what the second mathematical language, Boolean algebra, right? And the third one, which is applied on Boolean variables, and then predicate logic. Right? So predicate logic is it is the operations on well-formed formulas. So fuzzy logic is the combination of all these mathematical languages. So fuzzy language, I repeat again, it is a mathematical language, right? So fuzzy logic deals with fuzzy sets, as the other is applied on particular type of set. Similarly, this fuzzy logic deals with fuzzy sets. So we will learn further in the lecture that what is fuzzy sets, right? So fuzzy logic essentially combined like all the three languages. So it is a mixture of these three. Now we discuss what is fuzzy. What is the dictionary meaning of fuzzy? Yes, anyone will tell what is the dictionary meaning of fuzzy? Dictionary meaning of fuzzy. Yes, which is not clear, or you can say which is noisy, right? And the antonym, yes, yes, very right, vague, right? Fuzzy means vague, or you can say not clear or noisy. And what is the antonym of fuzzy? Antonymous is, yes, right, absolutely right. Or you can say in other words crisp. So antonym of fuzzy is crisp. Now we understand these two, what is fuzzy and what is crisp, with examples. Suppose there are two regions, right? And the two regions are separated by some boundary, but boundary is not clear. So you will say that two regions are separated fuzzily. Two regions are separated fuzzily because boundary that separates the two regions is not clear, right? Or you can say the boundary is fuzzy, or you can say the two regions are separated fuzzily. But if the two regions are separated with a clear boundary, then you will say the boundary is crisp, right? Because there is a clear demarcation between the two regions. Got it? Now these two terms clear? Fuzzy and crisp? Yes? Right. So your fuzzy answer may be, may not be, absolutely, partially, etc. Where there is some sort of uncertainty exists, right? So this is your fuzzy answer. Suppose if someone asks you that mm, whether you whether you ate at night or not. So your answer will be yes or no. Means you gave the crisp answer. You gave the answer in the form of yes or no. So this is the crisp answer. If you say, uh, like if someone asks that, but name the particular student, say Ankit. Ankit is honest or not. Someone say that he is he is a little bit honest. He is more honest. He is not very honest. So very honest, not honest. So where the answer may be in different forms, right? So it means these type of answers are the fuzzy answers, where you can't, where there is some uncertainty, or you can say answer is in many forms. When the answer is in many forms, you will say your answer is fuzzy answer, right? And and how, uh, and I give you one more example. First, I would like to This the concept of fuzzy system through some diagram. Concept of fuzzy system. First, let me draw the diagram and then I will explain. I am drawing the diagram for fuzzy system. Right here you have input. Input, and here you have fuzzy elements. Fuzzy elements and then fuzzy sets. Fuzzy sets, fuzzy rules. Fuzzy rules, fuzzy implications. Fuzzy implications, or you can say inferences. Right? And fuzzy system. And then you have this is the concept of fuzzy system. Right. So here you have input and output at the boundaries. So you have input and output. The main point is that you just note that we give input to the system in the form of crisp value. Right? We provide input to the this fuzzy system in the form of, means your input is in the form of crisp value. Similarly, the output should be in the form of crisp value. So in this system there are two boundaries, one is input and one is output. Yes, the important point to note is that input and output is in the form of crisp values, right? Input and output in the form of crisp value. However, input can be transformed into some fuzzy form, and then the fuzzy system comes into play. So in this type of fuzzy system, there are many constituents, as you can see here. In between input and output, you have many constituents of fuzzy system. You have fuzzy elements, fuzzy sets, fuzzy rules, fuzzy implications, and fuzzy system. So input is provided in the form of crisp set, and then it is converted into some sort of a fuzzy form by the fuzzy system, right? And finally you get the output in the form of crisp values, right? And in the next we will discuss about each of the constituent of fuzzy system, like what are fuzzy elements, what is fuzzy set, fuzzy rules, fuzzy implications. We will discuss one by one, right? Got it? First, we will understand what are fuzzy elements and what is fuzzy sets. So we understand these two elements with two things with the example, right? We understand these two things, what is fuzzy elements and what is fuzzy sets. Yes, students, are you getting? Everything is clearing now? We first understand what is fuzzy set and what is fuzzy element. Fuzzy set. To understand the fuzzy set, it is better first we have the idea of crisp set. Okay, fuzzy set से पहले हम crisp set को discuss करते हैं कि crisp set क्या है. Crisp set, right? Suppose you have a set named X, which denotes the entire population of India, which denotes the entire population of India. And you have another set H, which is derived from X, which is derived from X, uh, and it denotes to all Hindus, all Hindu population. So this H set, you can say H is the subset of X. And the elements are H1, H2, H3, and so on up to HL, right? And next you have another subset named M, which denotes all Muslim population. M1, say M2, say M3, right, up to. So these are H and M. These are called crisp sets, right? Because the members of, like, if I say the members of that belongs to H, right? Like H1, H2, H3, they belongs to only a single set, that is H, right? And similarly, all the members of M, that also belong, that only belongs to set M. Means if M1 belongs to M, it cannot belong to another subset like H. It does not belong to H. So members of M1 belong only to one set, right? So I can draw it diagrammatically also. Crisp set can be clearly defined by the graph also, like it can be clearly described through a graph, like this is the X universe of disclosure, right? Discourse universe of universe of discourse, right? And you have another, this is H and this is M, means all members of H belongs only to H. They cannot belong to another subset. Similarly, this M members of M subset cannot belong to any other subset. Right? So this is the example of crisp set. Means H and M are crisp sets. Now we take the example of fuzzy set. On the other hand, this was the crisp set, example of crisp set. Now we take the example of fuzzy set. Fuzzy set. Let us take another, say y. Y is all is, you can say it is the universal set, and that denotes to all students of CSE. All students, excuse me, all students of CSE, right? And the one set is derived from uh, set Y, that is your universal set S. It denotes to all students who are all. It denotes to all good students. All good students, right? So you can say how you will describe it. S is equal to S, comma G of S, right? Such that S belongs to epsilon का sign आएगा उसमें, as इस तरह लिख देते करो, X belongs to Y, right? And what is here? Uh, this is the fuzzy set, in which how you will define that student is a good. There is no clear-cut demarcation that you cannot say that this is a good student. You have to define the degree with this. That this student, how much goodness is with this student, right? So in the fuzzy set, you define the element and along with its degree measurement, or you can say measurement of element, right? So in fuzzy set you will define two things. One is the element itself, a student in this case, right? And then the degree of the degree of his goodness, yet how much he is good. You have to define the degree also. So you can say fuzzy set is the ordered pair of elements, where you have to define the two things. Ordered pair. Ordered pair means it should be in order. Element should be in order. It should be defined with its degree also. First you will define the element itself, and then you will define the its degree. Like for example, Example, S is equal to say Rajat, comma 0.8, then comma Sumit 0.1, and then Salman 0.7, and so on. So here you you are defining the fuzzy set with the student itself, and his degree of the element, degree of the goodness. Rajat है तो how much good he is, right? And Sumit, then Sumit is good. Then how much good he is? Then you have to define the degree, which is called, you can say, membership value or measurement value or membership value. Dear students, getting? So fuzzy set is an ordered pair of elements, right? So these are the fuzzy elements, right? These are the fuzzy elements: element 1, element 2, element 3, and so on, right? So these are the fuzzy elements, and S is the fuzzy set. Yes, got it. And this is called membership value or membership function, membership value. It is called membership value, right? Or degree of measurement, or you can say degree of measurement. Membership value or degree of measurement.
How to use?
Right? Now we will compare these two terms, crisp set versus fuzzy set. Yes, this is clear. Fuzzy set and crisp set is clear. Yes, I repeat again, as you can see, like if I'm in case of crisp set, I'm talking about crisp set. If the H and M belongs to the universal set X, right? So each member of H, like H1, H2, H3, it belongs only to one set, that is H, right? And similarly M1, M2, M3, it belongs to only one subset M. But in case of fuzzy set, for example, if you have another set, take another subset, say you can say G, or you can say B, which you can say which denotes bad students, all bad students, right? And B is, and this B subset is derived from this Y, right? So means, and then same students can belong to set S and set B, right? Because like if I say B is equal to, then I will take all students, like if I say Rajat of degree of goodness is 0.8, but degree of badness is 0.2, right? And one more important point to note is that the membership value always lies between 0 and 1, inclusive 0 and 1, right? So note this point. The membership value always lies between 0 and 1, inclusive 0 and 1, right? So if Rajat's degree of goodness is 0.8, then Rajat's degree of badness is 0.2. Similarly, if the Sumit's degree of goodness is 0.1, then his degree of badness is 0.9, because 1 minus 0.1 is 0.9. And similarly, if Salman is having the degree of goodness is 0.7, then what will be the degree of his badness? Now, yes, you will answer. Anybody will answer? What is the degree of his badness? Very good, Lokesh. It means, as you can see, the same students can belong to different subsets, right? Means Rajat is belonging to subset S and Rajat is also belonging to subset B. Similarly, all students can belong to more than one set, right? But in case of crisp set, one member can belong to only one subset. There is a clear demarcation, right? But here, one element can, in case of fuzzy set, one element can belong to more than one subsets. Now we will compare these two. Crisp set and then fuzzy set. So here the first point to note is that S is equal to S such that Sx S belongs to X. Right? On the other hand, if I take fuzzy set, how I will define it? F is equal to, it is the ordered pair. It is the ordered pair of elements S, comma, mu of S. We define the membership value with the symbol mu of S. This you have to define with two things. One is the element itself and second is its degree of S, or you can say degree of element, right? But in the crisp set you have only one element, such that S belongs to X. In crisp set you have a single element, but in fuzzy set you have two things: the element itself and his membership value. And the second difference is, it is a collection of elements. It is a collection of elements, and it is a collection of ordered pair. It is a collection of ordered pairs, right? And the third difference is inclusion of an element,
calculating like if you want to implement the concept of data hiding,
inclusion of an element S belongs to X into S is crisp. S is crisp, right? Means it belongs to only one set only. But in case of fuzzy, inclusion of element S belongs to X into F is fuzzy. That is, if present, it is with the degree of its member, right? So S belongs to X into F is fuzzy, right? This is clear. The difference between fuzzy set and crisp set and fuzzy set. And next, the important point to note is that a crisp set is a fuzzy set, but a fuzzy set is not necessarily a crisp set. What I told you, fuzzy set, sorry, a crisp set. Fuzzy set, crisp set. Crisp set is fuzzy set, but a fuzzy set is not necessarily a crisp set. How I will justify it? I explain this through example. Suppose I have a set H is equal to H1, H2, 1, H3, and so on. So this is the crisp set. H is the crisp set, you can see. Right, where the membership function is 1. When the membership function is 1, then all the elements will belong to only, then that element whose membership function is 1, that belongs to only one set, right? That cannot belong to another set. Or you can say this crisp set is a fuzzy set because you can skip this one. One just specifies that if his membership function is 1, that's why it belongs to only a single set. Or you can say crisp set is a fuzzy set. But you can't say that fuzzy set is not necessarily a crisp set, right? Because if in a fuzzy set you have the membership function, suppose in 0.2, 0.3, 0.4, so it means that element, that fuzzy element can belong to any other subset also. Yes, clear? Yes, time is over. You can leave the session and read this topic. If you have any doubts, then you can ask in the subsequent session, right? Okay, have a good day.